Hi, everybody. Thanks for hopping on to another episode of Device Squad, the podcast for the mobile enterprise from Propelics, an Anexinet company. Device Squad, fighting crimes against enterprise mobility worldwide. Bad UI, frustrating user experiences, poorly conceived mobile strategies, we defeat them all. This podcast series will cover all aspects of enterprise mobility, including strategy, development, design, testing, and more. My name is Steve Brickman. I'm a mobile strategist and UX architect with Propelics. First, a brief history of the company. Founded in 2011, Propelics is a mobile strategy consultancy helping enterprises worldwide devise true mobile strategies and develop world-class mobile applications across all industry verticals. Propelics clients include large companies like Amway, Bright Horizons, Bank of Montreal, Dubai Airports, Family Dollar, DLL, Cintas, Merck, and many more. Propelics' menu of services includes 8 different mobile kickstarts, covering everything from mobile strategy and road mapping to MCOE to UI UX design to mobile testing strategy, along with soup to nuts app design development and support. Additionally, Propelics offers 3 homegrown enterprise mobile products. So today we are going to be talking about AI in the enterprise. And we have 2 guests with us today. We have James Hoshor. And James, I think anybody that listens to this podcast knows who you are. You are a mobile strategist with Propelics, an Anexinet company. And we have Michael Golub. Now, Michael, you lead Anexinet's digital and analytics services team, and you are also head of the machine learning task force at Anexinet. And let me just add that anybody who listened to the last episode of this podcast knows that Anexinet is the company that recently acquired Propelics. So we're happy to have you here on Device Squad.
Thanks, Steve.
Mike, why don't you tell us a little bit about your own personal digital journey before we get into the AI, and tell us how you came to be a machine learning guy.
Sure. So it all started, as it does with most people when it comes to things like this. It started with frustration, and that was to say, when I first graduated from Drexel, one of my specialties or my focus or minor was in what they called AI back then. And back then we were talking about languages like Prolog and Lisp. So coming out of school in 91, only to find that a few years later, the real advances, at least in America for AI, were helping fuzzy logic chips inside of a HVAC system determine whether to turn on or off. It really wasn't rewarding. So I switched and really focused more on digital. We didn't call it digital then, but years and years of playing at it off to the side has finally paid off, because machine learning is back in a big way. I will say Canada never gave up on it, which is why they have so many more experts. But the journey was a roundabout one through companies like QVC and Accenture. And here I am today working with a really talented group of people, both throughout Propelics and Anexinet, many of whom have joined our machine learning task force, where we're tackling a lot of real world problems. And our mantra is do as little as possible. Start with the small algorithms, work your way up to neural networks.
That's great. Thanks. So today we'll be talking about a number of things around AI. We'll talk about AI's evolution over the past few years and its journey from a personal to professional use. We'll talk about who are some of the top players in AI today. We'll discuss what AI adoption looks like for the enterprise for this year, and where we think AI provides the most value in the enterprise. And we'll also talk about any potential hurdles that companies might face in their journey to implement AI. So, James, what have you been seeing in the evolution of AI over the past couple of years, specifically with relation to its journey from personal to professional use, which seems kind of counterintuitive?
Well, I think it's like mobile technology was 20 years ago, right? We started using that personally with Blackberries and the PDAs and such that came out. And then ultimately, once we found use cases where it could be used in our professional careers and started out with just basic things like getting emails, calendar functions and things like that on a mobile device. And we've now seen in all the personal experience how mobile has really made an impact both professionally and personally. I think we're going to see the exact same thing with AI. We're seeing that a lot of companies, and especially a lot of clients that Propelics is working with and Anexinet's working with, are already starting to ask the question. So as we're going into our strategy engagements, they're talking about chatbots, which is one of the technologies and solutions that is driven by AI from behind the scenes there. So we're already starting to see companies trying to figure out how do we introduce chatbots, how do we introduce machine learning and AI into the enterprise. And I think it's just like, as I mentioned, with the smartphones and the tablets and wearables and stuff, if we find a way where it makes sense to use it and we identify those use cases, there's always going to be, somebody's going to find investment or budget to go introduce that, and especially if it's going to drive value. Michael, I mean, you are working in this space a lot more than I have been. So what's your thoughts around that?
So I agree with everything you've said, and I would add to it that one of the things we like to say as we're engaging early on is one of the worst reasons to use AI or machine learning is just because you think you should. And I know you agree that you need to start with the problem. So we're seeing clients now making the shift from, I think I need to do this, and what would you do, to, hey, we think we have something live here, and this would be a great example to introduce some automation or some anomaly detection. And the client space is getting a lot more savvy, both through education, in talking to each other, and from companies like Anexinet and Propelics, helping to prepare a path through some of those use cases.
Yeah, I mean, I think it always helps our audience if we give some examples of some use cases. So, Steve and Michael, I had a couple here that I thought were pretty exciting things for what AI has been introduced to already. So, the first one was healthcare. Obviously, healthcare. There's a lot of ways technology can improve patient care and engagements and doctors and so forth. And we're seeing a lot of AI adoption now in the healthcare industry. And there was one case study I found out there. There was a large electronic healthcare records vendor called eClinicalWorks, and they launched a virtual assistant called Eva, and it's really targeted to help doctors and other care providers find patient information more efficiently. So, doctors can order a prescription or ask for a patient's medical history, and unlike Amazon's Alexa, this solution is actually built into the computer versus just a standalone device like you would have on your coffee table or kitchen counter and stuff. But I think what we're seeing with AI in healthcare, it's really becoming a game changer in there. And it's really making the doctors and the other care providers a lot more efficient in their daily task and the time they're having to spend on just even some of the common tasks out there. So a couple examples I thought were worthwhile mentioning is, for example, if a patient calls to request a medication refill, today or in the past, the physicians, have to find several pieces of information before they can place that prescription refill order in there. And so they have to look at when the patient was last seen, what are some of the medications that they're taking as well, what's the patient's most recent blood test show, et cetera. And so instead, now with AI, a doctor having to search for this information is simply able to say, Eva, let me see James' patient records for the last 3 months. And then that is all provided right there by simply just using AI technology, just like we do in our homes, with Alexa, asking what the temperatures are going to be, or asking Alexa about a favorite TV show or something. We're seeing that type of technology being introduced already out there. We're also seeing it in the banking industry. Some of the top banks like JP Morgan Chase are already introducing contract intelligence platform designed to analyze legal documents and extract important data points and clauses out there. And they've seen a pretty significant benefit for that. So what was normally taking them like 12,000 annual credit agreements, 360,000 man hours to do, they're now being able to do that literally within a matter of seconds, which is unheard of. It's crazy. And then you look like the Bank of New York Mellon Corporation, they announced last year that they've rolled out over 220 different types of chatbots over the last couple of years that are handling tasks that are often repetitive in nature and normally handled by their staff. And their results have been crazy. I mean, they're looking at the reported 100% accuracy in account closure validations across 5 different systems. They're seeing 88% improvement in processing time, a quarter of a second robotic reconciliation of a failed trade versus 5 to 10 minutes by a human. So, I mean, the results are speaking for themselves. And so that's why I think there's a lot of excitement and adoption increasing more and more as we go through this year and we look beyond to 2020. And so
a couple of other things to mention, both within healthcare and banking. One of the areas where we're seeing a lot of interest and where we're helping people is in the area of anomaly detection. And that's where you can have a large corpus, a large group of data inputs from the social sphere and determine whether or not a drug is having adverse effects based on what people are saying out there in the world, in addition to forms that are being filled out. Another really cool thing happening in healthcare is within the realm of radiology and trying to do detections in radiology. You'll see that there are algorithms right now that can outperform humans, and that's not meant to scare anybody. The idea is to augment and to help people that are making these calls to move through that process quicker. And 2 within the banking industry that are also kind of interesting are signatures. And a signature is something you can look at, and it portends to, or it does a fairly good job of predicting an outcome. So there are signatures now that we're working on to try to determine fraud before it happens, and possibly even money movement signatures. And by money movement, that is, there are things that may be happening around an account that show that perhaps sometime soon a person may want to move their money out of an account or change it. So these are also a lot of interesting developments in the marketplace around prediction.
We did have a couple of recent podcast conversations with my friend Andy O'Feish, who is a blockchain guy, blockchain engineer, and he claimed that blockchain had no place in the enterprise, that it was just too inefficient for what it accomplished. And that sort of the tasks that you're talking about now and these benefits that you're mentioning, like tracking patient data and so forth, or verifying signatures, these are all sorts of claims that blockchain claims to perfect, basically, through distributed ledger. But is AI a better solution, or would the two work in tandem with each other, or what are your thoughts on that?
Well, Steve, I don't see the two of them as competitive, mainly because one is much more about a distributed ledger that is supposed to provide a system of trust between parties that allows you to make movements and changes through contracts and money, whereas AI, I think, as a term is really umbrella to begin with. But if we were to just narrow it down to machine learning, not to oversimplify it, but machine learning at its best is going to help us automate or improve individual decision-making tasks. And you can group them together into something more complex. I see the potential for some machine learning algorithms to help make certain interactions with blockchain more efficient. I don't think that they're actually going to improve, trying to mine. There's already specialized algorithms for that. But I don't necessarily know if there are a lot of use cases where you would have to make an either or decision with those.
Just a couple other ones to point out here. We are seeing, again, some of the top institutions in healthcare and financial and so forth leveraging AI and machine learning. Bank of America is one last use case here that they've actually created a virtual assistant named Erica that's been launched. It's a chatbot that leverages predictive analytics and cognitive messaging to provide financial guidance to the company's over 45 million customers. So here we're seeing, instead of using it to maybe provide value to the employees of the bank, they're actually using it to drive better experiences with their customers and making their engagements more enjoyable and more effective with them. And so that's powerful in itself. And then we're already seeing that Amazon obviously created Alexa for home, but now they've launched Alexa for business. And that's really targeted more towards office employees in some of those mundane tasks that they do, like creating calendar appointments, dialing into conference calls, accessing and viewing customer files, just like we mentioned with the doctors and stuff. So I think, it's here. It's not going away. I think the adoption will go as fast as people find use cases for it. And like Michael said earlier, they've got to start out small. They've got to find specific problems or use cases and go, at it that route versus trying to launch this big bang approach to it. And I think if they do it that way, just like any other technologies, they're going to see the value of it quicker than trying to do a large approach for it.
So in terms of like voice interaction, do you think that obviously Google has a huge leg up, but do you think companies like Amazon and maybe Apple already have a huge leg up since they're already invested in AI interactive hardware? And do you think that they'll be able to dominate because of that?
Well, I don't know if they'll dominate to the extent that no one else has a chance in the marketplace. I think they do obviously have a little bit of advantage because they've started out in the consumer space and have been able to prove success there and the value it has delivered for us in a consumer aspect. But, you look at IBM with Watson and, there's over 1,000 different types of vendors or companies out there that are investing billions of dollars today in AI technology research and machine learning and chatbots and so forth. So I think while some of the big players are well-known brands out there, like you said, with Amazon and Google, have been more prominent, with their launch into consumer, I think you're going to see that quickly, just like Amazon in their first foray years ago to doing all the shipments and things like that. Competition is going to catch up to them. And I think that's where, like Michael was saying, AI is such a broad term, a broad technology to talk about, that you got to start looking more granular into the different types of AI, like natural language generation or speech recognition, as you mentioned, or virtual agents and so forth. And certainly we can talk about some of those here today.
There's also a bit of good news as regards using machine learning for competitive advantage. If you're a company whose mission is to provide the best translation tool possible, you've already got obviously really stiff competition with Google. However, if your mission is to provide some other good or service, and in order to get there, you need to employ machine translation, there are a lot of libraries from Google and other companies that you can use. So when machine learning becomes an aid, or it's something that's tangential to your business that's going to help you gain competitive advantage, then all of these players we've been talking about are really your friends. If you're in the market to provide breakthrough AI-based technologies to others, it's a little bit of a different story.
So that's one area that kind of confused me. I was recently at an AI conference here in Boston, and that was largely focused more on image recognition and identification of objects in images versus audio record. There was some audio and language processing there, but predominantly it was image processing. And it just struck me that all of these different companies are kind of working towards achieving the same goal of creating these huge libraries of interpreted video and just, building these huge data libraries. But like I was bothered by this idea, because doesn't it seem like ideally we should all be like creating one massive library?
Well, now that one is a very, very sensitive topic, and I'll introduce briefly this concept of bias. So bias is, when it's spelled with a little b, it's a really important part of machine learning. You need weights and biases in order for your algorithms to work properly. However, bias with a capital B is where things creep into your data sets. So I am somebody that really urges against, quote unquote, the one big data set, because with it comes a lot of unintentional side effects that are the result of just taking in speech that is freely available. These data sets that are used for natural language understanding, if they're not cured of bias, will have inbuilt isms. And by isms, we're talking about racism, sexism, all the terrible things that roll into a data set if left unchecked. That very same thing happens in facial recognition. I just posted on LinkedIn this morning about a particular trained model that becomes ineffective when trying to recognize certain types of faces. And part of the issue that we have here is that these data sets, not only they themselves need to be curated and be representative of all different people, but the models that we train also need to be neutralized in terms of unintended bias. So that may be a whole nother podcast for another time, but it's crucial. And what you brought up was really important. It's absolutely vital that we understand the data sets, what's going into them, and possible unintended side effects of data that's not representative.
Right. So even in that case, I mean, ideally is the best case scenario then to create a huge number of these data sets and then somehow compare them to each other?
Well, what I'd love to see is something like the FCC for artificial intelligence, where you need to show certain key markers about your model to prove that you've accounted for some natural bias. There are very popular, highly used data sets out there now, fueling a lot of research and new algorithms that has flaws in it in the way that worldviews are, continued to exist in it that aren't real. Differences between men and women that are not scientific, that actually show up in the data itself if not corrected. So I would say there should be many, many data sets, because you're going to always have a niche where you need to have a specific set that's being trained for a particular model. But we do need to start bringing in ethics and fairness into this. It's a very different world where the data creates the algorithm.
So where do you think AI will be able to provide the most value to the enterprise, given that these issues exist?
Steve, I think we've talked about a lot of examples already where we're already seeing it drive value, whether it's to improve how healthcare providers and physicians can get access to patient data more efficiently and effectively, which obviously frees up more time for them to treat patients, right? But certainly, if we can look at simple use cases, as I mentioned earlier, just allowing employees to be able to say, Alexa, schedule this appointment, or Alexa, start my conference call and things, just by just a little time savings in each one of those tasks, if that adds up over a day and so forth, certainly if you can get 10, 20, 30 minutes, an hour back in an employee's day that could be used towards something that's more critical or more important, then it's naturally going to start showing an ROI and driving a little bit more value proposition there for companies, from employee productivity and operational efficiencies and so forth. So obviously those are just some of the simple ones there. And I'm sure Michael's seen with his endeavors into AI and machine learning a lot more granular things than that as well. So Michael, what's your thoughts?
So the other thing that we see a lot of, and I'll quote Andrew Ng of Baidu and Google and Coursera fame, he has been noted for saying AI is the new electricity, insofar as how it's going to affect every industry. But moreover, one of the points that he says is, right now, the progression of the field and the maturity of the algorithms we have, AI is really good at doing things that takes the average person about a second to figure out, about a second to decide. This is just a rule of thumb. So one of the things that we see a lot of, as I mentioned earlier, is interest in anomaly detection. That's not only in healthcare. In retail, it would be very interesting if people were able to determine why was there a sudden spike in either interest or in lack of interest in a particular product. I'd like to pull together all the variables and gain some insight. So using supervised and unsupervised learning, we can reveal latent meaning within the data that might not have been available otherwise. And the other thing that we see is, through automation, the ability to move more quickly through a volume of decisions, freeing up the person that used to be specifically tasked to doing this low-level decision-making to do things within their industry or their company that require some higher order cognitive abilities. And by passing off some of the mundane work to the machine, now we're free to make some decisions that are a little bit more meaningful. And then the last thing, with natural language, there's very interesting use cases for something as simple as summarization. Years ago, the big trend was, let's turn everything into a graphic. Let's make it so that we can fly through a three-dimensional model of data points to understand things better. Well, now, lo and behold, what we find is that people respond well to graphics when it comes to immediately needing to see a lot to understand a trend. But when it comes to taking a next action, we, in our own minds, create a narrative. We talk to ourselves. We say, I now need to do this. So natural language can also take a large aggregate of data and create a summary, literally write a small paragraph about how your business is doing based on inputs. So that too is very helpful when it comes to doing prescriptive analytics.
That's really interesting. Let's just back up a little bit. And if you can just define the terms supervised and unsupervised learning.
Sure. So these you'll hear a lot as you start to delve more into machine learning. So in supervised learning, what we do is we feed an algorithm a set of data. We have a training set and a test set. And in the training set, we feed some data points in, and we tell the algorithm, these are how we'd like to classify these data points. So let's say we have the classic housing problem. When I feed you some data points and I give you the size of a house and the location, I'm also going to give you a label, and I'm going to tell you the price. And now I'm going to give you, hundreds of thousands of these. You're going to get the size of the house and the location, and you're going to get the price. And we train a model in order to predict what would the price be if I only knew the size and the location. So after having fed the model with these labeled training elements, and again, labeled means I'm giving away the answer. Okay, machine, this is your size, this is your location, this house is worth $300,000. Now the model is trained, and we're going to throw a test set at it, and we're going to say, okay, here's some houses. I'm giving you the size and the location. What is the house worth? That training set is unlabeled data, and what we're trying to do is predict what's that label going to be? What's the value of the house? So that's supervised. In supervised, we first give away the answers, and then we train the model in hopes that it can then predict answers. With unsupervised, we are not giving away the answers to begin with, and we are setting up an algorithm that will hopefully reveal some information about the data set or help us determine an outcome based on labels that were never given. So one thing that you can do with an unsupervised example would be machine translation, where you have sets of sentences and you load up an algorithm with sets of sentences, and the algorithm is able to predict the next word based on word frequency. And by comparing sets of words in one language to sets of words in another, and I'm simplifying this to the nth degree, you can accomplish machine translation. It's a complex algorithm. It uses LSTM, which is long short-term memory, and recurrent neural networks, and all that high-end stuff. But at the end of the day, these are unsupervised training models. So those are really, that's the basic difference between the two of them.
Great, thanks for that. So we had my friend John Hershey on one episode, who is a research scientist at Merle. Now he's with Google. And he was one of the scientists who solved the cocktail party problem, which is the isolation of a single audio or single voice in a room full of voices.
Yes.
Yeah, he's an amazing dude. And so part of that process involved filling in gaps. So that episode was all about how AI can fill in the gaps where data doesn't exist, because in that case, there's like crossover of voices that are either they were overlaying the same person's voice on itself and using that to create gaps in data, and then using prior data, like you said, to fill in those gaps based on predictive analysis of what usually came next. Is that something like what you're talking about with unsupervised? And where does that fit in with enterprise usage?
So that's really interesting. And the cocktail party problem, and now, of course, I'm just not going to stop harassing you until you introduce me to your friend. But we all stand in awe of that one, because early on, that was a breakthrough that allowed you to differentiate meaningful sound from non-meaningful sound. And one of the ways that you can train an algorithm, and I'm not sure if this is how they did it in the cocktail party problem, However, it gave rise to lots of research that does the following. We will record a speaker saying hundreds and hundreds of words, and then we will also record noise of various types. And that noise might be noise from a coffee house or noise from a street. And we will then take those same words and we will inject noise into the sound file, re-recording it automatically, and train the data set with noisy files as well. And what we're doing is we are hardening the algorithm. We are habituating the machine to understand the words even when there is noise and crosstalk, which is just brilliant. And the algorithms for doing that are actually a little simpler than you would think up front, because adding degradation to the file or noise will actually result in a model that is more robust, but you have to do it up front. And I just thought it was brilliant. This is actually something anybody can learn from Coursera, but the introduction of premeditated or artificial noise into a sound file that has thousands of words is just brilliant, and it's effective, because trying to get somebody to repeat all these words in the specific instance where there's sirens and cars and whatnot is obviously impractical. So yeah, they've found a way around that too.
Funny thing is, that's a much simpler explanation than I got from Hershey. So, I mean, since it's all done digitally, you can feed an unlimited amount of samples into this thing, right, very quickly, and then just automatically, I'm guessing, automatically add increasing amounts of noise or vary the types of noise, and then just keep saying, this is the word cat, this is the word cat, right? Is that kind of...
It's pretty close. Here's what's so brilliant about it. What you're doing when you're training the model is you're including instances of a sound very pure, instances of a sound with noise. Then we start getting really interesting, and instances of the sound said with various accents. So we can really do a lot to harden the model and make it more robust to the different failures it would encounter, both from the way that things are spoken regionally to the way they're spoken in various noisy places. And this all can be done fairly automatically. Obviously, accents need to be handled, using voice actors or recorded, but the idea of injecting the files with noise, it's fascinating, and it's something I experimented with myself and was just blown away at the results, that you can take the simulated noises and inject it, and just by properly setting up your data, you now have a set that's pretty robust and resilient against noise, which, as you know, is vitally important for companies like Apple, who need to understand what you're saying to Siri in any number of different circumstances. You're not always so lucky that you're just speaking in a quiet room.
Sure. And I mean, especially in the workplace, the utility seems pretty obvious. If somebody's in a loud workroom or factory, that kind of language processing needs to be super accurate. But
Absolutely.
Are there other applications for this kind of outside of voice recognition with image processing and things like that relate to the enterprise?
So convolutional networks are really at the heart of all of the facial recognition that's out there, at least at the current time. And what they're great at is being trained at a large corpus or a body of data of faces. And they can be used right now for facial recognition to gain access to computers and environments. So you can use them for authorization or authentication. They can also be used, and this is something I think that we're going to start to see. I don't know that anybody's out there doing it now, but they're becoming more and more reliable at associating faces with perceived feelings or emotions. So facial recognition uses something called landmarks. Landmarks are areas of a face that can be mapped, and as faces are reduced to strings of numbers mathematically, these are matrices in the algorithm, certain aspects around the landmarks are really what needs to be retained in order to train the models. So in these landmarks, based on how these landmarks will move around your face or how they are situated against a typical human face, you can infer somewhat reliably that a person is angry or surprised or joyous. Again, it's not 100%, and many people have different ways of expressing themselves, but the reliability starts to get closer and closer to human reliability. As we know, as humans, we aren't perfectly reliable at gauging what somebody's feeling either. But this sort of thing could eventually be used as a digital assistant or coach to somebody possibly in a sales role, just as right now we have solutions even within Anexinet where we can help call center people improve based on the interaction between a call center agent and a person dialing up who's a customer. We can track the sound of the voice as well as the implied meaning to determine whether or not that conversation got angrier as it went and who it was that became angrier. So these things are all here now. And I could see the same happening within the realm of the visible, where you can track an interaction and see if somebody's perhaps losing interest or frowning or excited by what was just said, and then start to catalog that and use that to improve as well.
You know, it just occurred to me, it's pretty ironic that the same technology could be used to assist people who are on the spectrum who have difficulty either making eye contact or reading faces for emotion, that they might rely on a machine to help them identify what somebody else is feeling or expressing.
Correct. And I think one of the things that we've got to be careful about with that is when we're training these models, based on the data, we're going to train these algorithms, and the models need to be not just simply large so that we can be efficient. Many times what you'll hear is, I need more data. What I'll get on my soapbox again, we need more data, and we need data that is fair and representative so that all faces of all types can be recognized and regarded. And that's a really big deal. And that doesn't even get into, after having accounted for all different people and treating these data sets fairly, what will the usage be? What will we do with the fact that we've inferred somebody may be feeling a certain way? And this raises a whole lot of other issues, but these have been around ever since we started down big data and making decisions around it. But I would just say it gets more and more important to consider the usage and the ethics behind this as we go.
Why buy just a video game from Atari or Intellivision? Invest in the wonder computer of the 1980s for under $300. The Commodore VIC-20. Unlike games, it has a real computer keyboard. With the Commodore VIC-20, the whole family can learn computing at home. Plays great games, too. Under $300, the wonder computer of the 1980s, the Commodore VIC-20.
Coming soon, Commodore brings you Gorf, the Wonder arcade game, and Omega Race in home versions. Commodore.
So we talked a little bit about a data hurdle that corporations will need to deal with when implementing AI, but what other kinds of hurdles in terms of infrastructure and things like that will corporations need to be aware of?
There's a couple different things that we're seeing out there, Stephen, and from a network and security standpoint, certainly there's a lot of disparate data systems out there. That the challenges that we're seeing with implementing collaboration productivity tools such as AI around that is, how do you, like Michael's been talking about, is how do you pull the data together? How do you make sure you have the right algorithms? How do you make sure that you have the right data to the context of the business problem you're trying to solve, right? Because you can have all the data in the world, but if you don't have it, in a highly granular format, and you don't have the right storage mechanisms and so forth, at the end, it's not going to do what you want it to do, and which causes frustration. So, and certainly I think you're going to see a lot more focus on hiring the, data engineers and folks that can come in and help make sense of the data, make sure you have the right algorithms and so forth to generate the right value from that. So I'm sure Michael definitely has some thoughts around this.
So I'll just throw in two things to consider. So when you ask yourself, do I have the right data? One of the things you can do to help answer that question is either from within your organization, if you have somebody that has enough machine learning acumen to try to run a simple classifier on it, that'll help you, because you can see whether or not you've got enough training and test data. If you need to pull somebody from the outside, there are people that can help. There are data scientists and engineers, as we've discussed. A lot of companies will come running to give you a hand, but right up front, making sure you have the right data has to really end up with a training set that you think you can use to make reliable predictions, and a test set that's good enough to make sure you can test your accuracy. And then the last one is the data ready to be used. So there's the ability to take some data and to format it for ingestion into a machine learning algorithm. And you'll do things like scaling, you'll vectorize it, you'll do all this, but then you need to really be concerned about data curation, because you're probably going to want to update that model from time to time. And that's another thing where we'll see that data curation is going to be just as big, I think, going forward as getting your data into a state to begin with to start experimenting.
The other thing that outside of the data that is going to be starting to cause some hurdles is the culture of the organization, right? And so as you introduce new processes, new technologies and things out there, the culture is going to be impacted. And I've already been hearing that from some of the clients that I've been working with, just as we're talking about introducing different strategic concepts like a mobile center of excellence and governance around how mobile is being adopted and applied in the enterprise. We're seeing some pushback already just on things of a common nature around mobile technologies and the concern of the culture impact it's going to have, especially when you're looking at companies now starting to have to reevaluate their current business models and their processes, determine if and where AI and mobile technologies, machine learning, et cetera, can really drive value. And I think that is also going to be something that companies have to consider just as much as having the right data and also making sure that they're ready to use that data. Michael, what's your thoughts around that?
So it's interesting you bring culture into it, because where we have culture, we also have a lot of the intangible things that go around it, such as commonly held beliefs, shared group identity, and a lot of the things that help keep a culture together can also, in a way, be a binding force against something new unintentionally. And AI, unfortunately, carries with it some positive and some negative aspects. And I think as we start transitioning from using words like AI and we start to talk more about, okay, this is machine learning, and then we get even deeper and we say, oh, we're doing some classification or we're doing some predictions here. I think as we demystify it, we may be able to sidestep some cultural concerns within companies. And at the same time, some of the concerns may be well-founded, because while I don't believe in the dire predictions that, that the Elon Musks and others have, that, AI is going to become this treacherous overlord, I don't see that happening. I don't think we have to worry about Terminator and Skynet. I do think we do have to worry about job displacement, and that there may very well be lots of jobs right now that require repetitive decisions that could be automated. So while we can't sidestep that and pretend it's not happening, I think at the same time we can't fall into the trap of looking at this like some ominous, terrible thing that's ready to break out of its cage and kill us all. So from a corporate culture perspective, I think that there is a rightly concerned group within any company that needs to be heard, and there's probably just as many people that are fearing something that doesn't need to be feared.
Yeah, and I agree with that. I think you brought up an interesting point about the fear of the unknown, and people are thinking AI is going to take our jobs, and we're going to displace all of a sudden 1,000 employees out into the unemployment lines there. And that's certainly not the case. I think we're already seeing that AI and machine learning and chatbots and so forth are there to help employees be more efficient and more effective in their jobs, which gives them back more time to do other things that drive even a greater value to organizations. So I completely agree with you. I think if you take the scary words and everything out of it and you educate people in the right context of how this is going to help do your daily task, or how this is going to improve customer engagement or your experience when you go to see a doctor, then people's perceptions and things, their walls kind of start to be let down, and they will start adopting that, right? Just like we've seen with mobile. I think everybody was scared of mobile technologies. I know my folks are, 75 years old, and they were, scared to even think about using a smartphone. Now I can't get the darn thing out of their hands, and they're calling me every day just as they're kind of their tech support guys saying, how do I do this now? How do I do this? And they're starting to use Siri, and they're starting to use Google on their Android devices to ask questions and so forth. And they've become addicted to it now because they've seen how it can, help them do things a little bit faster as far as finding information and so forth. So it's quite humorous, but in the simplest form of AI from Siri and things like that.
Yeah, what's fabulous is when your folks say, call James, and it accurately predicts that they would like to call you, they're right there using some of it, which is fantastic. And it's another interesting thing is that the algorithms now are getting to the point where a lot of the work is now happening on board, whereas just a few years ago, and even today, because there's still much of it that has to go up to the server in order to get interpreted, but a lot more of the work is being done on device as we have new toolkits that can actually take some of these libraries and models and run them right there from the palm of your hand.
So now, Michael, you lead the machine learning task force at Anexinet. Do you feel like companies should start implementing these kind of task forces as maybe part of their digital center of excellence? Is this something that companies will need a body to oversee the implementation of documentation and the rules and to create consistency throughout the organization and so forth?
So I would say this. For our clients, for the larger companies of the world, and the Fortune 500s, if you're not actively trying to grow some internal machine learning acumen, then I think you have to align with a vendor and at least develop a position or a roadmap. And if at the end of doing so, you determine that you are intentionally and deliberately not introducing any sort of machine learning or AI into your enterprise, that's fine. But I would suggest doing it deliberately versus waiting until your competition does something and perhaps you wish you had. There may be industries where it's really not going to yield a lot, but now is the time. I would say, not this month, but this week, this hour, this is the time for leadership within all companies to ask the question, are there things that we are doing that would be improved in terms of accuracy or speed with automation? Are there bodies of data that we should be mining for latent information? Are there tasks that if we were to make them easier for our internal people or for our clients to take on with the help of machine learning, that would give us competitive advantage? So now is definitely the time for those questions. But I would say that we ought not to look at machine learning like a hammer and now we're just looking around for nails. There are instances of people that just wanted to employ a neural network into their environment so they could say the AI is in my organization. Sometimes it's not necessary. You can do something much simpler with machine learning, simpler classifiers. This is more about let's get the job done versus let's use the latest, greatest research in order to solve your problem.
So given that, what do you guys think enterprise adoption of AI machine learning looks like this year?
Well, I think like the examples we've been talking about, it's going to be far greater than anybody probably would have imagined, years ago. There was an interesting report that I read recently that Forrester published at the end of last year, and they were showing in some of the surveys that they've done that companies were spending less than $8 billion in 2016, and now they're forecasting that there's going to be a spend of over $45 billion in the next couple of years by 2020 in AI and machine learning and so forth, and that 51% of their executives that they surveyed were already actually investing in AI, which was up significantly by the number of 40% from 2016. And 70% of the company execs said that they were implementing some level of AI solutions in the next year. So I think it's pretty strong results from the survey here that's showing that we're there already. Just like we've been talking about, it's making sure that they have the right data, the right approach, that they're solving small specific problems first, proving it out, getting people to see the value of it. And once they do that, just like any other new technology that's been introduced into the enterprise, people will recognize that and it'll, catch on like wildfire, just like mobile devices have in enterprise now, where now you have an average of 5-6 devices that employees are bringing combined, personal and corporate devices. So I think we're going to see a similar adoption rate here in the next year or two.
And who would you say are the big players currently when it comes to enterprise AI?
Well, I think there's, like Michael mentioned earlier, the AI is so granular. You got to look at the different types of AI technologies out there. So, when you look at natural language generation, which is basically producing text from computer data, and we're seeing a lot of those uses in customer service and report generation and summarizing business intelligence insights. There's a couple of vendors that come to mind, like a TVO or Automated Insights or Cambridge Semantics or SAS. Then you look at technologies like speech recognition we were talking about, where you can transcribe and transform human speech into formats that's useful for computer applications. So we're seeing this currently being used in like interactive voice response systems and mobile apps. So vendors like NICE or Nuance Communications or OpenText or Verint Systems are some of the top players out there. And then you've got virtual agent technology, so simple chatbots that we're seeing out there in customer service or the smart home manager. So like Amazon's Echo, Apple's Siri, Google's With Their Home, IBM Watson, Microsoft Cortana. Those are the more common ones and big players out there. And I think the last thing, like with Michael's forte in with the machine learning platforms, where we're actually providing algorithms and APIs and development and training toolkits for data design and train and deploy models that can improve our business processes that really are going to span a wide range of enterprise applications involving prediction and or classification. Then it's vendors like Amazon and Google with their TensorFlow or Microsoft or SAS out there. So, I think you got to look at the specific niches out there. And I think that's also causing a problem too for IT execs and business execs, because there is so many different applications and different technology platforms for AI and machine learning. I think people are really kind of scratching their head going, which ones do I pick? What's right for me? And that's where you have to, like you were mentioned earlier, you have to build a strategy and figure out what's the right application and start small and grow from there.
You've nailed it in terms of all the big players. I would throw in, when we're talking about some of the speech recognition, as a little plug for Listen Logic, where we actually pull together a lot of different algorithms in order to provide some pretty reliable predictions around what's being said and why within the call center. And it's a very interesting platform that pulls together a lot of the things that you mentioned. But without taking up too much time on that, I would say under the concept of platforms, there are also some little known sleeper hits, I think, that we're going to hear a lot more from, like Gradient from Paperspace. And why you're going to hear more about these is because they allow you to experiment and they save you some time. And I'm sure we've all had this moment where you read the marketing literature on something and it's not speaking very glowingly about a particular instance. And then you say to yourself, yep, I'm that person. And things like Gradient and some of the others you mentioned apply. And I will say I am that person, and not in a flattering way, where you look at the lit and it says, don't spend hours and hours and hours installing GPUs into your machine and downloading the latest Anaconda distribution and trying to make it work all together and putting the latest libraries in. And of course, all of us that have been experimenting with this for years have done just that. And then here come, the Microsoft Azures and the Amazons and Google Cloud with all of their AI workbenches, and the machines that you can use, these VMs, they're decked out with GPUs that have 3,000 cores available, and you can access them and pay by the second, if you will, for machine time. And everything's always up to date. It's the latest distributions. It has all of the good data science packages on there that you would want. Everything from, scikit-learn to TensorFlow and Keras. And, it's all just right there for you. And you can rent it and do your experiments on it. So we live in an interesting world where you can now get access to very niche specific environments, and you can spin them up long enough to prove something to yourself about your data, spin them back down, maybe make a production version of it. And all of these things, like you mentioned earlier, James, cause a lot of confusion for the folks that are heading up the development arm of companies or the analytics arm. So where do I start? Which one do I use? And some rules of thumb there would be start small. And by starting small, what I mean is try the most inelegant, least sophisticated algorithm first and work your way up. These various providers have claims to fame that are slightly different from each other. You're going to get a different experience on Azure than you will with Google Cloud, than you will with Amazon. Each kind of has its own pros and cons.
Thanks. And lastly, I just want to go into sales mode for a few minutes here and talk about what Propelics and Anexinet can do to help an organization that's looking to either just explore AI technology or already knows what it wants and is looking to implement something.
From a Propelics standpoint, one of the big things that we always preach and certainly think is important is to have that digital strategy. So in doing so, you have to look at the maturity of your organization across IT and business, and looking at people and process and technology, and especially in the technology perspectives we talked today with network and security infrastructure, making sure that you have the right platforms in place, the right security measures, data readiness and quality, that you're going to be able to support the continuous delivery and so forth. So making sure that you understand the maturity, where those gaps are, and defining a roadmap that helps fill those gaps prior to embarking on some of these emerging technologies out there, we feel is certainly one of the critical first steps in this journey, right? And then looking at from a people process, as we've talked about today too, is you are going to have to reevaluate some of those business processes out there and determine how incorporating technologies like AI or machine learning will impact that business process, but in a good way, right? And then looking at the people aspect, and like Michael was talking about, you don't need to run out and hire a bunch of data engineers or scientists and so forth. Leverage companies like Anexinet and Propelics to come and assist initially from that perspective. And as you start small and you start seeing the value and you start expanding the solutions that you're now incorporating across your enterprise, then you can start justifying the measures of hiring your own internal resources that can take it and grow with it over the years there. So Michael, from a Anexinet standpoint, talk about how your group certainly can come in and assist in helping companies out.
Absolutely. So James, one of the things that I want to echo that you said is you have to have a strategy, and we can open up the doors and the windows and just let some of the smoke out when it comes to this hazy world of AI, where things are, I think right now we would all agree, it's a little bit overhyped at this point. You can't turn around without hearing the term. So the Malta team can get involved and start small and work with you to really talk about, as crazy as it sounds, and this is really where we like to begin, how little can be done in order to do your first experiment. How small of a data set could yield a result? Which department is least likely to upset the apple cart if we started to do these experiments? And it's very much about a pragmatic, step-by-step, brass tacks approach, where we talk directly about the algorithms we're using and why. We can even show you the math behind it. A lot of it is stuff that you learned in high school. It just happens to be compounded by the use of a lot of matrices and whatnot. But one of the words that I really would like to leave people with when it comes to the Anexinet Propelics approach is demystification. We really like to get to the bottom of a thing and show pragmatically what's useful, what provides ROI, what have others done in a similar situation, and where can you start in a way that's easy to comprehend and to get a quick win on.
That's great. Thanks so much. So full disclosure, I checked in with my friend John Hershey to see about doing a future episode with you, Mike, and him on the same episode to get more into the weeds on machine learning. And he's telling me that now that he's at Google, they're a little more tight-lipped about this stuff, and that possibly if we alter his voice.
We've got an algorithm for that.
That's right.
That's fantastic.
We'll have to explore that possibility a little more, I think.
Fantastic.
Guys, thank you so much for hopping on today. That's been a really informative talk.
My pleasure. Looking forward to the next episode.
Absolutely. Thanks, Michael.
And thank you for hopping on to another episode of Device Squad, the podcast for the mobile enterprise from Propelics and Anexinet Company.